Hello and welcome back to my channel. My name is Piyush and this is day 54 in CK 2025 series. And in this video, we'll be looking into pod security and security context, Linux capability, and all the related concepts related to the security in Kubernetes, especially the pod security. And in this video, we'll be doing hands-on demo, we'll be doing some tasks from the exam perspective and from the fundamentals of pod security perspective as per the new CKA curriculum. And yeah, that was updated recently in February 2025, and everything is also available, like all the content and all the practice exercises, all the code snippets, everything is available in the GitHub repository of the CKA series. I'm sure you will find the link in the description. So yeah, let's start with the video. Let's start with understanding like what we'll be covering and what are these concepts, right? So pod security in Kubernetes has two specific subtopics or two specific parts. First is security context. Okay, so the security context over here, and the other one is Linux capabilities. Okay, so what are these? Let's try to understand these first, and then we'll look into why do we need these. Okay, so Linux capabilities, or should we start? Okay, let's start with the security context first. So security context defines, so it's written over here as well. It defines privilege and access control setting for pods and containers. What do we mean by that? It means like when you start a pod, when you start a pod or a container inside it, like what are the different aspects of the privileges to it? Like, so we have different security contexts, so such as run as user, that defines the user ID to run the process. Okay, so when you start a container, there'll be a root process running, the which has the PID of 1, process ID 1. So what will be the user of that container process? Okay, so let's say you start an nginx container, so that nginx process will be running with which user, whether it will be a user like such as Ubuntu or nginx or root user or any other user. So we defined that using a parameter called run as user inside the security context. Now this security context, where does it go? You can apply that, it's written over here as well. You can apply that at pod level as well as container level. I will show you that in the demo once we do that. But now try to understand, in a manifest YAML, you have pod related details in the spec, you have container related details in the spec. Okay, so these security contexts you can apply at both the level, at the container level, at the pod level as well. So let's say you applied at the container level, that means let's say you say run as user is 1000, so this is the user ID, so that means the container process will be running with user ID 1000. Okay, similarly we have run as group, that means the group ID. So when you start a process, there is a user ID and then there is a group ID. So multiple users belong to a group, such as a developer group, an operator group, or an admin group, a DevOps group, right? So this particular process, the container process or the pod, it will be running with which particular group? We define that using run as group. Okay. Then then we have run as known root. What do we mean by that? It ensures that containers or the pods, it cannot run as root user. Okay, this is important from the security perspective, right? Because if you are running a container using a root user, that means it will have a lot of permission. It can do a lot of things if gone in the wrong hands, or if someone accidentally start a process that was not meant to be, then it can do a lot of harm to the host operating system, to the host machines, to the node, and to the overall Kubernetes cluster, right? So this is important. This is one of the most important security measure, like should not run the process or the container as the root user unless it is absolutely mandatory. Okay, so we define this can be defined with the value true or false. Okay, so run as non-root, that means the process should not be a root user. So if we do that as true, that means this is what as per the security standards. If we run as non-root equal to false, that means the process will be running as the root user. Similarly, over here, when we run the process as a user, so 1000 is like a user. It's not a root user. But if we need to run a process as root user, we specify the ID as 0. So if the run as user has been specified with the value 0, that means we are running the process as a root user. Okay, now let's move forward with fs group. Fs group is, so whenever we mount a volume on the container, right? So and when we specify, let's say, fs group as 2000, okay, this means the files inside that volume or the directory itself will be owned by group with the id 2000. So this is for file ownership. So there's a difference between run as group and fs group. Run as group is specifically of using which group the process will be running. It is for the process, but fs group is for the file ownership. Okay, then we have allow privilege escalation. So again, this has the values as true or false, and it simply means that it controls if a process can gain privilege access or not. How does a process gain privilege access? Such as, let's say, sudo su, or even switch user to a root user. Okay, so when we define this as false, that means the process cannot run these privileged command on the container or at the pod level. Okay, so this is the security context. Now inside the security context, there is another field which is called Linux capabilities. Okay, now what is Linux capabilities? It defines what a container can do. Okay, it is because, like I have specifically mentioned over here, it defines what a container can do because it is applied at the container level only, right? Like the security context that we have seen earlier, it is applied at both pod level as well as container level, but this Linux capabilities are only applied at the container level. There are different capabilities available. Okay, and again, it defines what a container can do, means the restrictions that we imposed on containers, the process it can run, the capabilities that it has, or the commands that it can run, right? So these are three, like the most common Linux capabilities. So first is cap netadmin, cap sysadmin, and cap systime. So cap netadmin is mostly for network administrator, such as, if it provides you ability to update or create network interfaces, make changes to firewalls or routing tables. Okay, so this is mostly the network specific tasks. Okay, so unless the container or the pod needs these capabilities, this should not be added, right? Then we have cap sysadmin. So cap sysadmin is mostly, as the name suggests, it's mostly used by system administrators, right? And the capabilities include mounting the file system or creating or deleting the file system mount, and making any sys configuration changes, kernel parameter changes, and so on. Then we have cap systime. It is to set the system clock, system or hardware clock, and it is mostly used by NTP clients or time sync services. Okay, so that's the Linux capabilities that we will be looking into in detail with the help of demos, but there are others as well. There is an important term to understand here is drop and add. Okay, whenever we need to add any of these capabilities, we add inside the capabilities block, we do add, and then in the double quotes we provide the capability name. Or if we want to add all the capabilities, which is not obviously secure, it is not something that you should be doing, but let's say you have to do it for test purpose or some learning purpose, then you write all keyword inside the capabilities. This is how you will add the capabilities. And if you want to drop the capabilities, so inside the capabilities section you add drop, and inside drop you provide the capabilities, or if you want to drop all the capabilities then you drop all. Okay, I will show you in the demo. Okay, so yeah, let's go ahead and let's do the demo. Okay, let's me open the playground, and feel free to use whatever playground that you have, or like if you have any um okay, I just lost my word. Okay, so if you have any Kubernetes cluster running, feel free to use that. Okay, and what I'm using is a code cloud platform. It is free to use. You will find the link in the description, and I have used it previously as well, so it works fine for our demo. All right, so what are we going to do? We are going to start with the capabilities. Okay, capability management. Okay, so I have a YAML, and again these code snippets, YAML, everything is there in the GitHub repository, so don't worry about that. So let's call it cap.yaml, and I'm gonna explain it to you as well. Okay, so what it is doing, it is creating a pod with the name secure demo. It is using nginx alpine image. Okay, container name is app, and inside the container, so at the container level, remember I told you that the capabilities can only be applied at the container level. Okay, so inside the security context, I've added, first I have dropped all the capabilities, that means the container does not have any capability, and then I've explicitly added two capabilities. One is netadmin, another one is systime. So with this capability, we should be able to create or delete network interfaces to the attached to the container. And with this capability, we should be able to set the system clock. Okay, so and if we try to do anything else other than these two capabilities, it should show us permission denied. So let's apply this and then we'll test the changes. Okay, so I'm just gonna run kubectl apply -f kappa and get pods, container creating. Oh, it went into error, crash loop back, I don't know why. So let's check it out. Describe pod secure demo. Okay, it says let's see, terminated. There is, okay, maybe some permission issues. So okay, logs secure demo. Okay, it says operation not permitted. Maybe it's trying to do something that it's not allowed. Okay, so that's one check for the capability. Okay, what it is trying to do that it is not allowed. It says John, because we are running an nginx pod and it is trying to change the ownership of a particular directory, which is not permitted because we have used drop all permission. Okay, so let's delete this pod and we'll just change the image. Okay, delete pod secure demo. All right, so let's go ahead and let's change the image from nginx to let's use busybox image, busybox, and I'm gonna add a command as well, because otherwise busybox, it's a type of image that will exit if we don't provide any command to it. Okay, so I'm just gonna add sleep 1 hour. Okay, I think it should work, but we'll see. kubectl apply created. Let's see, get pods, run container error. No, I think that command is not correct. So what we need to do is, let me check the repo. Okay, I have to provide sh as well along with it. Okay, so let's do that, and I'm gonna use a specific image for busybox 1.28. This is one of the latest images, and let's over here, let's provide sh hyphen c and then sleep 1 hour. Okay, we need to pass the command to a shell, right? Okay, hopefully this time it will work. So let's apply the changes again. Okay, it's not letting me update it because I'm updating the command. Let's try to make the changes forcefully. If not, we'll delete it. Okay, let's delete it and then we'll make the change again. So delete hyphen f. Okay, because we have made the changes to the YAML. Okay, delete pod secure demo. What was it deleted? Okay, it was deleted. So let's apply the changes again. Okay, get pods container creating. Okay, now this time it is running. Okay, now we have added certain capabilities. Let's test those capabilities. Okay, so first I'm gonna do is exec into the pod kubectl exec it, and then pod name was secure demo hyphen sh, so that will open a shell into the container. Now if I run, okay, so what changes did we make? We added actually a couple of capabilities, so we need to test if those capabilities are working fine or not. So first let's because we have the sysnet admin, so it should be able to create and show or delete the network interfaces, right? So let's do ip show. Not ip show, actually it should be ip link show. Okay, let's clear it and let's run it again. ip link show. Okay, so we have two allo and eth0. Okay, let's try to create a new one and let's see if it is permitting us to do that. So the command for that is ip link add and dummy 0 and type is dummy. Okay, now let's do an ip, come on, ip link show again, and you see the dummy 0 has been added. Okay, so that means our capability is working fine. Now there was another capability in which we have uh, added the sysdate type capability, right? So let's run date. Okay, so date is this, and let's run date hyphen s dollar date. Oops, date hyphen s dollar date inside double quotes. It says invalid date, but it is not throwing us the permission error, right? Let's see. So we are setting the date with date hyphen s, and maybe it needed a particular format. So so let's give some value, okay, to it. Let's 2025 month is, okay, let's change the month to May. This is June right now. Okay, and then 10th. Invalid date because no, it shouldn't go inside this. Okay, can't set operation not permitted. Okay, now if I run date, okay, it's not allowing us, even though we have, did we have sys capabilities? I think we had, right? So let's check the YAML once again. Systime, yes, we had the capability, so it should be able to allow us. Let's do that again. Date hyphen s, operation not permitted. Okay, sudo command not found. Can't set date. So let's try to, maybe it's not allowing us past date. Let's try to set the future date. 18th June. Okay. Yeah, it's somehow it's not permitting me to do that, but I will check it later on and I'll update the GitHub repository why it's not letting me do that. Let's move ahead and let's try to mount the file system. Okay, so mount hyphen t tmpfs and temp test. Okay, so now it says permission denied, are you root, because I did not provide this capability, plus my root user using which I have logged in, it's not a root user, it does not have privilege escalation as well, so that's why it is denying me the permission. And yeah, so we have tested the permissions. Now the only permission that I'm not sure why it's not working is the date. So check it out and let me know if you found the answer, and we'll move forward now. So the next one is the security context. Okay, so I'm just gonna add another YAML. Okay, so let's call it sec.yaml. Okay, now what does it have? So it has a pod, and over here is the security context. So this security context, it's applied at the pod level because this is directly inside the spec section. Okay, so that's inside the pod. Run as user 1000, that means the process ID will be running as user 1000. Group ID of that process will be 3000. Run as non-root true, that means it will not be a root user. Fs group is 2000, that means any file that we create inside this volume will be created with the 2000 as the group. Okay, now this is the volume which is of type empty directory, and it is using a busybox container that has the same command. We are mounting it on the path /data/demo so that we can create some files into it. Now there is a security context at the container level as well because it is inside the container section. Okay, now it has run as root, run as user 1000, run as non-root is true, that means it's not a root user. Allow privilege escalation is false, that means we should not be able to do su on that. And capabilities drop all, it does not have any capabilities at the container level. Okay, so let's apply this and let's test this out as well. Apply hyphen f sec. Oops, there is, what is the issue? Maybe they both are running with the same name. Sorry. Forbidden pod update may not change other field. Oh, is it? Okay. CK get pods, secure demo, and I believe. Okay, let's delete this pod. I think they both were with the same name. Okay, it's taking some time. Okay, let me force delete it. Hyphen force, and I mean to delete a pod forcefully, this is the command hyphen force and then grace period equal to 0. Okay, done. Now let's apply the changes again. Okay, created get pod. Yeah, that has the same name, that's why it was throwing us the error. Okay, now that we have applied it, let's try to check the let's try to test the changes. Okay, so kexec, okay, I can use the same command kexec 8 secure demo sh. I'm inside the pod now, so let's run ps first. Okay, now as you can see, the process that was running, this is at the container level, it is running with the user id 1000, and all the other processes are running with the user id as 1000. If it was 0, that means it was a root user, or it will be printed root over here. So that's first test. Now let's go inside the directory slash data. This was the volume that was mounted. Inside data there was a demo, right? So demo, as we can see, it was the group ownership is 2000, which is what we have specified in the YAML. And if we go inside this demo and create a file, so let's call it touch test. So this file has been created with the user 1000 and the group is 2000. Okay, so this is what we have set over there. And then if we run id, it will show you that user id of the container is 1000, the group id is 3000, and these are the groups. So there is one fs group and then there is group for the process. Okay, and if I'm able to do su hyphen, then it says must be su id to work properly, so permission is getting denied and sudo command is not there. So if I do su hyphen root, okay, it's not letting me do that. If I do ping 127.0.0.0.1, okay, it is throwing me permission denied, are you root? This is again a capability that comes with privilege escalation, right? So we have tested all the things that we have entered in the YAML. So let's check the YAML one more time. What does it had? So run as user, run as non-root. We checked with the ID, it was with the 1000 and the username was 1000 ID. Allow privilege escalation is false, and rest all the capabilities were dropped. Yes. Then it was mounting the volume on this particular directory, and we have checked the fs group of this was also 2000, which is file ownership group. And we checked with the id 1000, 3000, and everything was there, right? So we have tested all those things. Now let's test, just give me a second. We have checked this. Okay, now let's uh, test with the root user as well. I'm sure you would have gotten the idea till now, like how does it work for the root user, because we have created a non-root user. So let's create another pod and let's call it root.yaml. Okay, now um, it has a container named root container using busybox image, which will sleep for 3600 seconds, and run as user is 0. That means it should be running as a root user. Now kubectl apply hyphen f. Okay, get pod. Okay, one thing you might have noticed, and over here you see now sleep 3600 is working fine over here, but earlier we were getting error because we were providing the command all at once sleep 1000. Oh no, maybe because that was another type of image that we were using in busybox. It works. Okay, so now if I do kexec hyphen it root user test and hyphen hyphen, um, we need to check the user id, right? So we could do ps or we can do id. So let's do id, and over here you see the uid is 0, which is root. Gid, that means group id of the process, is also 0, root. And groups, it has 0 and 10, which is wheel, a default group, right? So a group root user test has been also done. Okay, now let's go back. There is another demo. There is one more demo left, but before that I want to cover some more concept of pod security standard. Okay, so let's go back over here. Okay, so now we have seen Linux capabilities and security context. Now Kubernetes, oh, where is my pen? Okay, over here. So now Kubernetes has provided some security standards using which we can have some groups, okay, groups, predefined groups created, which has all these things inbuilt. Okay, what do I mean by that? Let's look at this example over here. So we have three security standards. One is privilege, one is baseline, and one is restricted. Now, as you can see at the y-axis, we have security, and x-axis have restrictions. So over here, restrictions, it has this particular security standard has the highest restrictions. Okay, and it is highly secure. So what are the restrictions in that? So that means it should be running as a non-root user. um, it does not allow privilege escalation, it's false, right? And all those things like what we have discovered, it does not have, it has only the limited capabilities, okay, or the safe capabilities, like it does not have net capabilities or sysadmin, whatever is required, only that it will have. Similarly, the baseline is the middle one, which will have which will have some restrictions and basic security over here. And the privilege does not have any security, and it is least restrictive. That means it will have all the capabilities. Okay, so let's take this comparison as well, it will provide you more details. Okay, so restricted, baseline, and privilege. Okay, restricted has highest security, only safe capabilities are allowed, and it has strict restrictions because the name is restricted itself. The baseline has medium security, some capabilities are allowed, and basic restrictions are there. Privilege have lower security, all the capabilities are allowed, and it has basically no restrictions or only the safe restrictions. Okay, so that's another exam question that you could see. So let's go back to our terminal and let's try to do another hands-on. Okay, so I'm back over here. Okay, so the exam question could be like create a restricted namespace and configure the restricted pod security standard. Okay, so for that, let's create a namespace. kubectl create ns, let's call it restricted ns. Okay, k get ns, the namespace is created over here. Okay, now we need to apply the pod security standard label to this namespace, because using the like these pod security standards can be applied to particular namespaces, and then these standards will be enforced on those namespaces. Okay, so let's apply the label kubectl label on the namespace, and namespace name is restricted ns, and we need to add certain um, labels, right? So what are these labels? I'll just copy paste from the documentation, and I will share that in the GitHub repo as well. So it's over here. Pod security Kubernetes IO enforce equal to restricted, audit and is equal to restricted, and warning is also equal to restricted. Okay, labels. So if I do k get ns hyphen hyphen show labels, you should see all the labels that have been applied. Other namespaces don't have these labels. Okay, now I'm gonna create a pod that is compliant with all those things. Okay, that is compliant with the restricted pod security standard. So let's call it pod1.yaml. Okay, so what does it has? Because this is a restricted pod security standard, and you can, like, you don't have to remember what does it have or what's the main security context difference between a baseline or a privileged or a restricted. You can check this in the documentation, which is available in the exam as well, right? So this is restricted, that means it will it won't have any root user access. So run as the root user, run as non-root user, true. run as user 1000, group 1000, fs group 1000, and then seccom profile type runtime default. And I mean, this is just a test, right? So you can add it or you cannot. You should, like, it's totally your wish. Then at the container level as well, allow privilege escalation is false, non-root 1000, and capabilities drop all, because remember we've discussed the the privileged, sorry, the restricted would not have any capabilities by default, so that's why we are dropping everything. Now let me check the namespace. Yeah, namespace is correct. So kubectl apply hyphen f pod 1.yaml. Okay, it has some error at line 23. Let's check. Set list, what's the error? Oh, okay, there is a tick sign over here. Okay, let's apply again. Okay, k get pod. Okay, in the other namespace. So let's provide the namespace, restricted namespace. Send crash loop back. Why? It should not be. Let's check. And let's provide the namespace as well. Failed container app in this. Terminated. Exit code is 1. Okay, let's check the logs as well. K logs. Compliant pod. Okay, so basically we are getting the same error that we were getting earlier because of the nginx image. So let's change the image and let's use busybox 1.28. Let's add a command as well, which is sh sh hyphen c sleep 3600. Okay, I think I would have to delete and apply the changes again. Yes, so delete pod compliant pod hyphen n restricted namespace. Okay, deleted. Let's apply the changes again. Okay, get pod restricted. Okay, it's running now. Now it is running because it was compliant. Let's try to apply a pod that is non-compliant. Okay, so I have another pod with a lot of violations. So pod 2.yaml. Okay, and let's review this and let's update the, okay, this time it is using engine. Let's not take the risk. Let's use the busybox image. Busybox 1.28 command sh c sleep 3600. Okay, so it has security privileged uh, equal to true, so it's a violation. Run as user equal to 0, which is a root user, which is a violation. Allow privilege escalation is true, which is again a violation. It has a couple of capabilities, but at the namespace level, because we are using the restricted pod security standard, and as per that, the capabilities are all dropped. So these two capabilities would violate the pod creation. And then we are also using host path. Host path is also restricted in the restricted pod security standard. Okay, so it has 5 violations. So let's see what will happen when we apply the changes. Pod2.yaml. Okay, so as you can see, it says error from the server, it is forbidden. Pod security violation is forbidden, and these are all the violations that it has, right? It says restricted latest privilege container, must not set context privilege equal to true, allow privilege escalation is not equal to false, and blah 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 blah, all those things like netadmin sysadmin capability is restricted, volume type run as non-root is not. So it has thrown all the security violation as per the pod security standard, right? So this should have been failed, and it has been failed, right? So that's what we wanted to test. You can also check the event in the kubectl get events for that namespace restricted ns. um yeah, it only shows the normal or warning. I guess it's not showing the error out. um yeah, it's not showing it, but that's okay. So yeah, that's what we wanted to cover. We have covered everything from the exam perspective. Actually, we have covered more than what we need to know from the exam perspective. So I hope you found it valuable. I hope you found it helpful. Thank you so much for watching, and don't forget to watch the next video of the series, because next video going to be the last video of the CK 2025 series, and then we'll wind up this series. We'll start a new one, and let's get the fun begin. So thank you and have a good day. Take care, happy learning, and keep supporting. Thank you.